In this video, I'm going to be describing what point-slope form is and how we can use it. Point-slope form looks like this. There's actually two different ways we could write it, but this is the most general form of the point-slope form. Y and x are always going to remain variables. They're representing the coordinate of a point anywhere on the line, any point. We're going to get specific when we use the point-slope form, and we're actually going to plug in coordinates. We're going to plug those coordinates into the y1 and x1 spot. Those are going to represent coordinates of a specific point that we're going to use. And m is going to represent the slope. We're going to substitute a value there. So we're only substituting values into the y1, m, and x1 spot. And we're leaving that y and x by themselves. They'll remain letters. Point-slope form comes from the slope equation. If I have y2 minus y1 over x2 minus x1, my rise over run representing my slope, I can actually multiply both sides by that denominator, x2 minus x1, canceling it on the left side, leaving y2 minus y1 by itself on the left side, and now having slope times the quantity x minus x1 on the right side. And there's our point-slope form. So it comes from the slope equation. You can actually add y1 to both sides and get it into this form. There's another way that we can represent point-slope form. And actually in that form is a hint towards future math classes where you'll actually see function or equation forms of graphs written very similarly, where m is going to represent actually a scalar in this form. X1 is going to represent a horizontal shift on the x-axis, and k is going to represent that y1, and it's going to turn into a vertical shift on the y-axis. So when you get into functions and function notation, you'll start to recognize that point-slope form coming back. But today we're just going to focus on this form, y minus y1 equals m times the quantity x minus x1. So first, let's be able to write the equation of a line given a point and a slope, just substituting the most basic information into the equation. If I'm given point A at the coordinate negative 3, 2, and I'm given the slope of the line at which the point lays on, the slope is going to be 2, I can write the equation of the line in point-slope form. Point-slope form gets its name because you're using a point, a specific point, and a slope to write its equation. So my x1 value is going to be the x coordinate of my specific point. The y1 value is going to be the y coordinate of my specific point, and m is going to be my slope value. So we're just plugging these into the correct spot following the recipe of point-slope form. So y minus 2, plug in y1 value right there. Plugging in my x1 value over here, so I have x minus negative 3. Be careful there. If your coordinate is a negative, be sure and include that negative with it and that minus sign as well. And then substitute our slope value, 2 for m. And then the only simplifying you may have to do is with those double negatives, just turn it into a positive. So here's our line in point-slope form. What happens if we're given 2 points rather than a slope? Well, first, we want to find the slope so we can put it into point-slope form. So given 2 points, we know how to find the slope between the 2 points using our slope equation. Subtract the y coordinates on top, subtract the x coordinates on the bottom in the same order, and we get our slope, negative 2/3. So now I have a choice. I can choose either of these points, just choose one point, and use your slope and write it in point-slope form. So if I choose the coordinate 6, 1, writing it in point-slope form would give me y minus 1, put that y value right there, equals negative 2/3, put my slope value there, times the quantity x minus 6. I'm putting my x value over there. If I had chosen the coordinates 3, 3, I could have wrote my equation in point-slope form, but it would look slightly different. Now I'm going to substitute 3 into my x and y spots, and my slope into the m spot. And so we got 2 different equations representing the exact same line. So with point-slope form, even though your equations may look different, they may actually represent the same line. The only way to tell is to put it into slope-intercept form and see if you get the same answer. So if I take both of those equations and solve for y and put it into slope-intercept form, I can verify that they are actually the exact same line. So I do that by solving for y. I'm going to distribute my negative 2/3 to everything inside these parentheses. Negative 2/3 times x is negative 2/3 x. Negative 2/3 times negative 6. I multiply my tops here. Negative 2 times negative 6 is positive 12, and then divide by 3, leaving me with plus 4 here. So y minus 1 equals negative 2/3 x plus 4. I just have to add 1 to both sides to solve for y and put it in slope-intercept form. So we get y equals negative 2/3 x plus 5. Let's take a look at that other equation and see if we get the same thing. So again, I'm going to use my point-slope form, convert it to slope-intercept form, first by distributing my slope inside everything inside these parentheses. Negative 2/3 times x is negative 2/3 x. Negative 2/3 times negative 3, well, negative 2 times negative 3 is 6, divided by 3 is positive 2. And then one more step, just add 3 to both sides, and we get y equals negative 2/3 x plus 5, the exact same equation. So we know we have the exact same line. It was just represented by using two different points in point-slope form. So point-slope form gives us an advantage in that we can write the equation of the line using any point and a slope, rather than slope-intercept form, which requires us to use an exact point called the y-intercept and a slope. It's a lot more freedom when we use the point-slope form. And here it is. Make sure you can substitute values into it. If you need to find the slope between 2 points first, do that and then substitute into your formula. And if you would like to convert it or need to convert it into slope-intercept form, just solve for y.